got a very special guest with the Engineers with Ideas group. Our special guest today is Josh Slingsby. He is a specialist in all things timber engineering. So without further ado, let's crack on with it. Josh, can you just introduce yourself and tell us a little bit more about your history and background in the sector?
Yeah, no problem. Good morning, Don. Good morning, everyone. My name is Joshua Slingsby. I'm a senior project engineer here at Urban Limited. So Urban are a specialist mass timber consultants, essentially, but we offer design, supply, and installation services. So everything that we do is looking from the initial design stages in line with RIBA, whether it's stage 2, 3, all the way through to manufacture, stage 4 and 5. And then as well, we do the fabrication and procurement through to the installation on site. So everything we do is considering DFMA as well as design for installation. My personal experience, I originally studied architectural technology. So I actually started looking at more of sort of the detailed design of buildings, and through my undergraduate degree started looking at mass timber, looking at CLT, doing most of my thesis was based around CLT and mass timber. That led to me taking on my initial role coming into the industry around 9 years ago was with KLH UK. So again, a CLT manufacturer in Europe, and then they have a design office in the UK, working on a more commercial role. Through that time, I took on structural engineering as a part-time master's, so developed and sort of sidestepped into the structural engineering world. And then I've been with Urban with near on 5 years now as a project engineer, and then going into senior engineering role. And yeah, so we supply projects, whether it's small residential houses through to multi-story residential, a lot of education. Most of our work's in the education sector, to be honest. And then everything in between, whether it's small, commercial, hybrid structures, but everything centered around mass timber and predominantly CLT.
Perfect. Well, absolutely the person that we want to have on talking about mass timber then. So just to dive straight into the questions then, I suppose what a lot of people wanted to know is aside from traditional timber engineering, what are the other options that are available if people want to use timber in engineering?
I suppose it's an interesting question. I suppose it depends on how people understand timber construction. You have traditional timber construction, so whether that's kind of stud framing, all the way through to what you see in a lot of residential projects. And obviously you can go to 3 stories even with traditional timber. Historical timber structures, we see that especially in the UK and in Europe, you see that everywhere, especially when you start looking at churches or Tudor buildings. So then you've got the whole conservation world around that and how you sort of restore historical timber structures, through to what we predominantly look at, which is mass timber. Now, mass timber is kind of all-encompassing for engineered timber solutions. So we predominantly deal with cross-laminated timber, so solid timber panels. So it's a panelized system. Easiest way to think about it is IKEA flat pack. So everything gets pre-manufactured in
Oh, I think I've lost you for a second there, Josh.
Okay, I think I'm back.
Yeah.
Apologies
Yeah,
about
you're
that.
back again. Sorry.
Yeah,
So you said
no,
the easiest way to describe
me.
it was the IKEA flat pack.
Exactly, essentially IKEA flat pack. So everything's pre-manufactured in a factory, put on the back of a lorry, delivered just in time to site. And essentially from our side, we'll produce essentially the IKEA instructions, they go to site and they install them. And traditionally this is not a full prefabricated system with finishes. This is a structural system, solid timber panels, and we can show some images in a few moments just to demonstrate what that looks like. And that's kind of looking at CLT as a panelized system. Then you can look at glulam beams, glulam columns, in terms of, again, another engineered product. So again, much more of a post and beam system, which can be integrated with CLT, for example. So we procure a lot of glulam frames as well. And then you start moving into sort of hybrid structures with that. And again, with a lot of these systems, you'll also potentially incorporate some solid wood, solid timber, and with that comes a lot of different species. So whether it's CLT, glulam, you can look at softwoods like spruce, pine, fir. Majority are spruce, so softwood coming from continental Europe, all the way through to whether you want it for the visual finishes or durability. You start looking sort of your larch, oak, birch, and you get on that side. There's additional sort of products out there as well. So you can start looking at LVL, so laminated veneer lumber, a lot closer to plywood in how it looks at its edges, but in terms of the structural qualities and how it's actually laminated, you're getting the additional structural capacity out of them. So there's a lot of variety out there from the mass timber world, which will enable you to do a lot larger structures and larger spans, for example. You can go taller. So the largest project that we have on site at the moment is up to 7 stories, a multi-story residential, which is almost a little bit of a, I'll show you a couple of pictures if my internet will allow. Just open the picture and share. Here we go, share screen. Let's see if this will. So for example, this is where we're at currently on site, and this is using CLT. There are some steel elements in there, there are some glulam elements in there, but this is predominantly a CLT frame. And this is to demonstrate sort of the size that you can go in comparable to traditional timber. So again, I think we're currently up to the 6th floor here, and it's a 7-story residential block in the centre of Cardiff. Full mass timber solution. And can I move across? Apologies, just close that button. And to demonstrate the actual panelisation, here you can see how everything is supplied and installed. And this is CLT panels. You can see the end grain here. The reason it's called cross-laminated timber is because essentially it's built up of multiple layers of what we call lamellas of different timber boards, and they're stacked 90 degrees to each other at each level, and then they're laminated. So with a glue and with a high pressure bonding, they're bonded together to give you a master panel. So for example, what you can see here, if you can see my cursor, it's on the left hand side, stretching all the way over here, which is around 10 meters, is a single panel that would have been craned to site, through to the element which is on the crane, which is an entire wall element with a door opening punched from there. So they manufacture panels 3 meters wide up to around 16, depending on the manufacturer. So you get these large master panels, and then from there, we're able to either nest the individual panels through, and that's whether you're punching a door opening or window opening, or it can be cut and further nested and panelized. So the lintels are individual elements. There's a lot of ways that you can essentially work with them. And you can look to incorporate and coordinate your services. So all your service runs are pre-cut in the factory. So for example, that's what these 2 little notches in the panel here are for some ductwork. And then on this project as well, because it's a multi-story and the use of the fire escape, the staircase couldn't have been a timber solution. So through what we do ourselves as well here at Urban, we design, manufacture and install steel elements where required. So again, case which replicates as it goes through the building, so you can then see the contrast of materials, how that works together, and how we're able to integrate them as close to a hybrid structure in certain elements.
Awesome. Well, thank you very much for sharing that. And I think that leads quite nicely on to the next question that we've got. A lot of people know that the mass timber is a more sustainable product, but I think people wanted to just know that how it actually reduces carbon footprint and how it actually promotes sustainability as well.
No, of course. I think, there's a lot of confusion with this, especially if you're in the engineering world and you're doing sort of carbon calculations. So there's quite a few. We won't get into that too much, but when you start using carbon calculations, there's a few things that, depending on the method, it might not account for when you look at timber. So obviously every material has some embodied carbon, whether it's through the extraction, through the processes that are being made. But the main thing with timber is it is a renewable resource, or typically, at least for everything that we do and all the materials and products that we use, they're coming from European manufacturers. So immediately there, they're coming from continental Europe, not the UK. And there's a key fact there for that is, I think the UK has around 10 or 11% forest cover. Of that, how much of that is structural grade timber that can be used in the structural industry? Again, very minimal. Whereas countries like Austria, Germany, all the way up to Switzerland, a lot of that central DAC region at least is around 30 to 40% forest cover. And of those forestries, they are working plantation forests. So they're still old growth forests, but a lot of them are plantation forests. And then on top of that, they're managed forestries. So obviously FFC, PEFC. So in terms of how they're actually being managed, and they're not just, sorry, the phrase just lost me there, but in terms of the way that they're managed, obviously the way that they're harvesting the timber, so the way that they're actually cutting them down and replanting. It's in a managed process, so you don't just destroy complete areas of the forest without immediately replanting or doing patch. You're doing sort of local areas where you remove them. And there's a lot of different ways within forestry of how they manage that to make sure that as much as you're always actually removing less than you're replanting. And so that you're keeping the cycle going. And that's one of the main things with timber there. And the reason for that
I think we've lost you a little bit there, Josh. Might have to just go back on that last point. Yeah, we've lost you a little bit there. I think you said the reason for that is...
Yeah, unfortunately I paused in time. I think I got a bit of a warning on that one. I can only apologise where it's done. Yeah, one of the main things is with timber, essentially it's a carbon sink. Forests are carbon sinks. As trees are growing through photosynthesis, they're absorbing the carbon and they're locking that into the timber itself, into the wood. Now, they're most productive at locking in carbon over sort of the initial up to 30, 40 years of its life as it grows. And then there's a certain point where actually the growth slows and the volume of carbon that they're able to take in is actually limited. So there's actually a lot of arguments for why it's beneficial for managed forestries and then utilising that timber in the construction industry, because as you allow a tree to grow, it locks in a certain amount of carbon. At some point, it plateaus off in terms of the amount of carbon it can take in. Then the timber industry is able to then come essentially cut down some of those trees, but you're not losing that in because it's locked into the timber. So then what you're able to do is then convert that timber and essentially that carbon store into a construction product and then lock that carbon into a building. So for every mass timber building, all the timber that you see in there, that has got locked in carbon for its. The question always becomes on the design of cradle to grave and how that operates with different projects, and that's a consideration for every material. But the fundamental principles around timber construction and sustainability is that concept of locking in that carbon. So buildings can be your carbon store, your carbon sink. So you can convert a town, a city into a carbon store itself, at least within the construction materials you use, in comparison to steel and concrete. You always need steel and concrete. They have their place. You need your concrete for your foundation, certain designs where you want steel. So it's always about considering where is it appropriate to use timber and where is it beneficial, especially when you're coming from a sustainability side. And that's kind of the main principles behind it. It's about locking that carbon within the structure itself as material. For example, with the concrete industry, to produce concrete, you obviously have to, you're digging materials out of the ground, aggregates, creating sand, transportation of that, and then so you're actually emitting the carbon as opposed to containing it throughout its lifetime. And the same with steel, the amount of energy that's required through the fabrication process of steelwork. So there's always some, with the forest industry, you're still obviously cutting down forests, there's still processes, there's still factories, there's still transportation. But it's all about considering sort of gross versus net. And the fundamental principle is the embodied carbon and how much can you retain within that timber and that building.
Okay, awesome. Very, very nicely put. I like that a lot. So I think another topic which you touched on before, I know obviously with the steel staircase, you mentioned the fire aspect of that as well. So just moving on to our kind of next topic of conversation, which is everything to do with fire. But how do you kind of approach fire resistance when it comes to timber construction? You know, we're talking especially in the larger scale buildings.
Yeah, so essentially there's a few approaches to fire design with timber. Now, the key thing to know about timber is, especially in this current climate, timber is technically a combustible material. But the main thing with timber is it chars, and it chars at a known rate. And the principle of charring in timber is that it creates an insulation layer, so a sacrificial layer that you can build into an element that you allow it to char, and it then protects the structural thickness that you require behind. So there's a few, depending on what you're designing for and what the building regulations require. So I suppose something I always like to make sure that I kind of discuss with design teams when we're working on projects is understanding what are the compartmentation requirements of a building. Do you need R, E, and I? So load bearing resistance, insulation in regards to temperature between compartmentation areas, as well as then the integrity for how does smoke and gases move through a wall buildup. So a key question is, where you have timber structure, does that need to be that full? Does that need to achieve the full R, E, and I requirements of those? Now, typically within building regulations, almost every structure will require the load-bearing structure to have a R rating. So, for example, the load-bearing capacity of a building does it need to be 30 minutes, 60 minutes, 90 minutes? And then how do you achieve that? So the basic way to approach it is it can be lined. So you can align that with fire-rated materials to achieve all of those, the R, the E, and the I. And essentially the timber structure, and this applies to concrete and steel, they can just be boxed in, intermittently painted, etc. And that can be taken care of by a lining contractor, etc.
I think we're having some technical issues. I think Josh will be back in just a second.
Okay, I think I'm back. Apologies.
That's all right. You were talking about the contractor.
Yeah.
You only disappeared for a second, and then you're back. Don't worry.
Yeah, I thought I did there. So I'm in a new little side office room, and so testing out new connections. So hopefully it'll hold out. So we're talking about REI and how essentially you can do partial encapsulation or full encapsulation utilizing the linings. So you're not using the timber to actually protect itself from the fire requirements or achieve the fire requirement. However, what we do in majority of our projects is we achieve the R rating, so the load bearing capacity in line with building regulations of 30-60 minutes through the charring of the timber. So essentially you'll design a wall thickness, a column, a beam based on the structural capacity. And then essentially what you're doing is you're increasing that thickness or depth, if you're looking at a beam, to allow for a sacrificial layer of timber, which can char for the duration required. So timber chars at a known rate. Typically it's around 0.7 millimeters per minute. And this is all within Euro codes. So this is codified within European technical standards. It's then covered by ETA, so European technical assessments with different manufacturers and essentially producers of the product. So whether it's glulam, CLT, etc. So it's all covered by there and through with a lot of testing and test data that backs all of this up. So it's all known char rates. And that's whether you do have various char rates, whether it's a horizontal element being a floor or a roof, or a vertical element like a wall. So there are various there are varieties in terms of the different how the timber actually reacts to fire and chars in terms of the rate, but it's all known. So as long as you bring in a specialist, they'll understand how to apply that in terms of, and how to design the thickness to account for that the required load bearing capacity in line with building regs part B. So for the 30 or 60 minutes, and it's kind of as in a simplified answer, that is essentially it. You're accounting for the charring and you're looking at that. It gets a bit more complicated when you look at the E and the I. And most of that isn't to do with the material itself or the products. Like CLT in itself can achieve even like a 90 mil thick wall panel could achieve REI 90, for example, so 90 minutes because of the way it's cross-laminated and glued. But where where it becomes more complicated and complex is in all the junctions. So where you have openings in the wall, where you have to panelize the system and you have joints. How are those being designed to not achieve the R, but how are they achieving the E and the I, so the insulation and the integrity? But again, that is all achievable. It's just working with the design team to understand where are these requirements needed in a building, and what's the appropriate method for it to deal with it within the timber structure or to deal with it with linings. And there's all pros and cons to both.
Okay, awesome. That was very well put and very well explained there. And I think, this is just, what I'm thinking about here is, what is your opinion of the acceptance of the use of mass timber as an alternative to, let's say, the likes of steel or concrete within the industry, particularly when it comes to speaking to clients about things like fire regulations? How have you found that it's kind of been adopted by the wider industry?
It's historic. Even it's not really that historic. So in terms of CLT and glulam's been around for essentially 170 and close to 70 years ago. So glulam at least 100 years. I think the first CLT building was actually in the 50s or 60s on a small scale house. In terms of in large scale production, especially in the UK, around 20 plus years, but only around the early 2000s really it came to the UK, and it's really been developed as a mass timber solution market. And the UK was really a pioneer of the CLT. At one point, we were hitting some of the taller buildings. I think it's Murray Grove in central London. I think that's around 10 or 11 stories, residential block, fully timber. But you can see how the industry is sort of having to catch up, or the building regulations are catching up with the industry, and we saw that following post-Grenfell, and how then building regulations weren't necessarily changed, or the review happened, Hackett review, etc. And there's a lot of developments within building regulations, and the use of combustible materials was limited within external walls of residential buildings in high rise, so above 18 meters. So post then, the industry's had, I wouldn't say a fallout, but there's been a lot of discussions around the use of mass timber, especially CLT, where is it appropriate? But essentially, we're in line with building regulations and what you can do in this country. You can go up to 18 meters being your firefighting height, and you can have a complete mass timber building, including the external walls. So it could be a full panelized system. It doesn't have to be looking at a post and beam option. As soon as you go over 18 meters, so I suppose to put that into context, that is essentially the building that I showed you before. Let's hope that this doesn't throw out the stream again, just to show. So this is up to 7 stories. Now this is under the 18 meter cap. It is on the limits, but this is why.
I think that image has thrown out the stream. I think we'll get Josh back in a second, but yeah, maybe that image has thrown out the stream a little bit there. But yeah, we'll get Josh back in a second. Yeah, but you can see. Yeah, I think that image had thrown out the stream there, Josh.
I thought it might. Okay, I might have to limit those for now and see if I can share some afterwards. So I apologise. Yeah, so essentially we can go up to 7 stories in the UK, more or less, 6-7 stories using mass timber, including the external envelope for residential buildings. There's still a lot of conversation around that. There's a lot of different reports and literature that are being put out there. So one of the largest ones, I don't know if we'll have any architects tuning in with us. I know this is Engineers with Ideas, but Wall Thistleton, they're a big driver of timber buildings as an architectural practice. Essentially, they're one of the leading practices in the UK, and also operate globally, pushing timber design and use of timber. But what they've released recently is a document called the New Building Model, which is a really interesting document. This was produced in line with kind of in line with the insurance industry as well, because that's some of the biggest concerns is around insuring the building, and that's where most of this is coming from. You've got the building regulations requirement from a health and safety point of view, and how a building's designed, and then how much then the insurance industry actually impacts that when you start talking about residential buildings and how that's developed. So that's something Wall Thistleton took a lead on, which in some respects was brilliant. And the document is actually a really good reference document. I would advise anyone who's looking into mass timber or CLT especially multi-story residential projects, even if it's only mid-rise, to look into that. Because that is, they call it the new building model because it's looking at using mass timber from the sustainability point of view, because they understand the need for that and why it's such a beneficial, a positive use of material. And what they look at is actually the detailing and best practices, whether it's to do with fire, moisture, just general detailing and protecting of that. And one of those topics that I do pick up on, and just one thing I find it's an interesting discussion point, I've not been able to have it with many people yet outside the office, is they specify not using, they essentially advise not using mass timber in the external wall below 80 meters as well. So, and I believe a lot of that is being driven by the insurance industry and what they were developing that with. So there's still a lot of, there's still a lot of movement happening in terms of where and how we should be applying mass timber. But I think the main thing here is this is all talking about residential buildings. So building regulations is always talking about, it's all about risk. It's all about performance. And then when you talk about fire, it's about risk. And so when you're talking about fire, it's all about, well, what is the risk category of the building, and then what is the requirements that it needs to achieve. So with a residential building, you're staying overnight, people are obviously asleep during the evening, so the risk category, if a fire was to break out, for the people to actually be able to escape the building, that's where that all comes from. So they're really going down the conservative approach, which is actually above and beyond what building regulations are requiring. So what you can build in the UK currently is up to 18 meters with mass timber in the external wall. But we're starting to see now a lot of literature, well, not a lot, a few pieces of report writing coming from certain architects and certain people in the industry and within the architecture, sort of going a bit more conservative on that. And that's not necessarily a bad thing. And it's keeping the conversation going. So it's really still a developing environment, fire design within timber. But the main thing is it's all in line with Eurocodes, it's codified, we understand the material. It's now getting into the nitty gritty of how the modern world works in terms of requirements for test data, confidence within building regulations. So a lot of building control officers are actually independent officers, not part of them. So it's their own individual PI that they're putting up against a building and how that's then able to be insured. So there's always a lot of hesitancy within the industry, and that's not just from a design side, that's all the way through to insurance, and essentially just getting sign off through building control. So the industry is really trying to work together to establish this, because obviously we all want to design not just beautiful and good architecture, but safe, structurally sound buildings that will last the design life. Because when you start talking about sustainability, 50 to 100 years. We're still in Victorian houses, most of the country. They've been around for over 100 years.
Yeah.
So we want to keep building in that way. So obviously, typically we're designing for 50 years for most new buildings in the UK. So we want to make sure that our buildings last that long, whether that's from a fire design or moisture. We want to make sure we're detailing, we're supplying buildings that, really are going to help us in the current, climate crisis that we like to describe it as.
Awesome. I think it's really well put there. And I think that kind of leads quite nicely onto the next section, where we're going to get a little bit more involved in the technical aspects of mass timber. But from my perspective, I am seeing a lot of talk about the use of mass timber in the industrial or logistics sector. So large warehouses, which obviously have large spans. But I know a lot of people that I'm speaking to are thinking about how mass timber is going to compare to steel when it comes to those large warehouses or large spans. So I was just wondering if you could share some light on that, about how we get those larger spans with timber.
Yeah, I mean, it's all achievable. Everything has their limits, even steel. When you think about large span, even in steel structural design, is it just are you talking about just a single beam element, or are you talking about a truss? And a lot of the time when you're achieving these, it's a truss system.
Oh, I think we've lost Josh again, but we'll carry on at truss system. He's back. It was a truss system.
I'm back. Yeah, truss system. So essentially the same with timber. So we've delivered quite a few sports halls as well. I'll save sharing any images till the end just to try and not throw, and we can try and go through a few projects potentially if we have time. And I can demonstrate some of the things that we've been talking about. But we've done a few sports halls, so between 20 and 30 metre span beams. One of the halls recently, only last year, was a 24 metre length beam, and it wasn't a truss, it was just a solid timber element. It was around 1.6 meters deep, so the depth has to be accounted for depending on the architectural design. So you do get larger elements to achieve clear spans with timber in comparison to steel. And that's just looking at solid elements. Then you get into the truss systems as well, which of course you can achieve. I mean, just look at typical traditional design, whether it's church roofs historically, timber frame, the timber trusses, through to our modern, like current housing, and especially how we build houses in the UK, they're trusses. Fair enough, they're not logistics halls, but in terms of, if you think how timber can be applied to create a structural framing and a structural system, timber has been used to create these in so many ways throughout history. And now with the use of engineered timber, so like glulam, you can then use a glulam truss system to achieve them. So we're seeing quite a few of the logistic halls come through, and if it's not the logistics halls, it's the data centers or the offshore logistics hall.
I think we'll get Josh back in a second. I think he was on data centers there. But it was very interesting what he was saying about trusses. I didn't think if it was going to be single span or a truss system with mass timber, but I think that's quite an interesting thing to think about there.
Yeah, I don't think you'll ever invite me back, will you?
So you're on data centers.
Yeah, exactly. Yeah, I think I'm gonna have to work on this connection. I do apologise. Yeah, so we see a lot of these. We're starting to see more of these halls come through, whether it's sort of the logistics halls or data centers, and clients wanting to use it. So it's being driven then by the industry itself. So people are wanting to use timber where they can, because they want to start having that sustainable material and looking at how they can have as positive an impact as they can with the materials they specify for the project that they're working on, and whether that's the architect or actually the client. And we're seeing a lot more.
I think we might have lost Josh again. What we'll probably do is just pause the recording for now, try and restore Josh's internet connection, and then be back in a couple of minutes. What I'll do, Josh, I'll just pause it for now, and then what I'll do is try and restore the connection your end, and then we'll go back live again. So just give us a couple of minutes, and we'll
Thank you very much.
Start things soon.
Apologies.